Welcome to BC Mnemonics. In this video, we're going to be going over each of the components of the planispheric astrolabe. So as you can see here, I've disassembled a planispheric astrolabe, and systematically we'll be going by piece, analyzing each component and going over its individual function. So beginning with the tympan here. This is arguably the most important piece of the astrolabe, as it features a latitude-specific depiction of the sky. So for any given latitude, you'll have one of these tympans, and for each latitude you plan to use the astrolabe at, you'll have to insert this into the mater. But taking a look at the actual lines and features of the tympan, we notice this grid-like matrix pattern. So this is essentially the sky with a coordinate system. So this baseline, this curving bottom of the grid, is the local horizon, with east on the left side and west on the right side. Now that reversal is a product of the stereographic projection used to create the planispheric astrolabe. In addition to the reverse directions, we also have south at the top and north at the bottom, again for the same reason. Now, as we can see, there are two sets of lines in this grid matrix, the ones rippling out in concentric circles, and the ones all sort of diving in with their points terminating at this small point here. And that small point is the zenith, the point directly overhead of the observer. These lines that all dive in and terminate at the center signify meridians. The lines at the circles rippling outward are the lines of altitude, known as the almocantors, signifying distance above the horizon. The center circle here, centered around the pivot hole, is the Tropic of Cancer, the path of the sun at the summer solstice. The second disk outward is the equator, or the path of the sun at the equinoxes. The outermost circle, which coincides with the edge of the entire tympan, is the Tropic of Capricorn, which is the path of the sun at the winter solstice. Now the next piece of the astrolabe we're going to be taking a look at is the rete. Now this rete works in very close tandem with the plate or tympan, rotating above it to model the movement of the stars and sun. But taking a closer look, we have this circle. This is the ecliptic, and it contains each of the zodiac months or zodiac positions of the sun, and thus is able to record the position of the sun for any day over the course of the year, and model its position as well, and that will become very important later on. Each of these small spikes is a star, and just like with the sun, they remain on the rete as it rotates above the tympan, modeling the positions of the stars over the course of the day or night. Next, we have the mater of the astrolabe. Now this is the central base upon which everything is stacked and nested, and it includes several features that are used in tandem with all the other components. So around the outer rim, known as the limb, we have the hour scale. Now this particular scale is in the tradition of Chaucer and is labeled with letters. However, each of these letters also corresponds to a numerical hour, with A being 1, M being 12 o'clock, noon, and so on. On the back of this, we have a couple different nested scales, as well as the shadow square, which is used for determining the heights or distances of objects. On the outermost edge, we have an altitude scale that is used along with the alidade of the astrolabe to measure the elevation of objects above the local horizon. Just inside that, we have the zodiac months, which can be used to determine the current Gregorian date, or from the Gregorian date can be used to reverse engineer the position of the sun in the zodiac. And the centermost ring, we have the Gregorian months, or the dates that we're most used to. Now, the next piece we have is the rule. This is positioned above the reat of the astrolabe and rotates to indicate both the position of the sun in the zodiac and the hour along the edge of the mater. On the back of the astrolabe, we have the alidade. Now, this is the component that is used to take sightings and to measure the elevation of objects or celestial bodies above the local horizon. It has these two sighting vanes that, when aligned, can be used to point directly toward an object and, again, signify its elevation. Next, we have these two securing pins. This one is the nut and is used to secure everything on the front of the astrolabe. And this screw is what penetrates the back of the astrolabe and anchors everything in place. Now, sometimes, rather than a nut, you'll have what's called a horse, which is a small horizontal pin that pierces the string and is occasionally carved in the likeness of a horse. Now, that's every component, but let's take some time to assemble the astrolabe. So, starting with the alidade here, we position that on the back of the astrolabe, securing it in place with the screw, which is then ready to receive each subsequent part. So, beginning with the tympan, we secure it in the mater, ensuring that it's locked in place with this bottom tooth, which keeps it from rotating. Above this, we have the reat, able to be rotated freely, modeling the sky. Above this, we have the rule, which again is able to rotate freely. And finally, we have the central nut that secures everything in place. That will conclude this demonstration, and I thank you for watching.